In 1623, Galileo wrote that the universe is a book written in the language of mathematics. For centuries, people have searched for a specific formula that translates those cold, quantitative laws into our emotional experience of beauty. The most famous candidate is an irrational mathematical constant, approximately equal to 1.618, known as the golden ratio. You will hear it cited as the universal blueprint for structural perfection. The story goes that this precise proportion dictates the design of ancient temples in Athens and the compositional balance of high Renaissance masterpieces. If this single geometric proportion truly governs what humans find visually pleasing, it suggests our sense of aesthetics is biologically hardwired. Recognizing specific ratios might have offered an evolutionary advantage, allowing us to quantify and standardize beauty across cultures. But there is a problem with this narrative. When we actually measure the objects we claim are perfectly proportioned, the math frequently fails. And if this ratio is absent where we claim it exists, its persistence reveals a lot more about human psychology than it does about the physics of the universe. We have to ask if beauty is an objective, mathematical property woven into the fabric of reality, or if it is a subjective projection created by a mind looking for order in a chaotic world. To find the reality of the golden ratio, we have to strip away the historical mysticism and look directly at the mathematical, biological, and cognitive facts. There are verifiable instances where nature uses this math. The most prominent example is phyllotaxis, the biological study of leaf, petal, and seed arrangements in plants like sunflowers and pine cones. This animated diagram shows how a plant grows new lateral organs. They emerge from the center at an angle of roughly 137.5 degrees, a measurement biologists call the golden angle. If a plant produced seeds at rational fractions of a circle, like exactly 90 or 120 degrees, the newly emerging seeds would stack directly on top of the older ones, leaving massive gaps of wasted space. Because the golden ratio is highly irrational, meaning it cannot be expressed as a simple fraction, it mathematically prevents exact alignment. The plant can cram the maximum possible number of seeds into its center. This is a purely mechanical logic, driven by survival and optimal resource distribution. However, this specific mechanical efficiency does not scale to all natural spirals. The chambered nautilus is universally presented as the ultimate biological manifestation of the golden ratio. Empirical measurements tell a different story. The nautilus shell grows in a logarithmic spiral, but its actual ratio of expansion averages around 1.310, falling drastically short of the 1.618 required to be a true golden ratio. We see similar discrepancies when looking at hurricanes or spiral galaxies. These dynamic systems form equiangular spirals to find physical equilibrium under the complex forces of gravity and fluid dynamics. Their actual winding ratios vary wildly based on their mass and age. The golden ratio is a naturally selected solution to a specific biological packing problem. It is a functional byproduct of chemistry and physics, not a universal template for all physical matter. The strict biological reality contrasts heavily with the ratio's reputation in art and architecture. For centuries, art historians assumed that Renaissance masters actively calculated this precise decimal to achieve aesthetic perfection in their work. Leonardo da Vinci's Vitruvian Man is frequently overlaid with golden rectangles to prove this theory. Yet da Vinci's own mirror script notes at the bottom of the page reveal his actual methodology. He based his ideal human proportions entirely on simple, rational fractions, explicitly stating that the head is 1/8 of the total height, or the shoulders 1/14.
This diagram of the Parthenon demonstrates how the myth is sustained through selective measurement. To fit a golden rectangle onto the facade of this ancient Greek temple, enthusiasts have to ignore the triangular pediment, omit specific steps, and constantly adjust their starting points until the math works out to 1.618. The Great Pyramid of Giza gets similar treatment. The ratio of the pyramid's slant height to half its base length is close to 1.618. Yet, historians note this slope is simply a byproduct of standard Egyptian construction practices, using a measurement of slope called the second, with zero historical evidence that the builders knew of this specific irrational constant. The modern belief that we possess an innate psychological preference for the golden rectangle traces back to 1876. Psychologist Gustav Fagner asked participants to select the most pleasing rectangle from a lineup and reported a distinct preference for the 1.618 ratio. Modern replications of this study show that participants were simply gravitating toward the middle of the available range to minimize cognitive discomfort, which is exactly where Fechner had placed his preferred card. The concept of a mystical aesthetic law based on the golden ratio is largely a 19th century European invention, retroactively mapped onto ancient history by enthusiasts looking for a unifying theory of art. Our persistent belief in this number is rooted in an evolutionary survival mechanism called apophener. This is the psychological tendency to perceive meaningful connections, patterns, and structures in completely random or meaningless data. Our brains constantly scan the environment for order to make the world feel predictable and safe. When we encounter visual stimuli that are ordered and symmetrical, our visual cortex processes them with very little metabolic energy. Cognitive scientists simply call this processing fluency. The easier an image is to interpret and encode, the more aesthetically pleasing it feels to the observer. We find the golden ratio visually pleasing because we appreciate distinct proportions and moderate complexity. The aesthetic pleasure is an internal reward generated by the brain, completely independent of any specialized mathematical receptor for the number 1.618. Today, the ratio is stripped of its divine connotations and utilized heavily in user interface design. Dividing a screen by a 1 to 1.618 ratio provides a highly functional grid system. It breaks up the picture plane, establishes a clear visual hierarchy, and creates a gentle trajectory for the user's eye to follow. Photographers use the golden spiral to place their primary subject at the smallest inner curl. This asymmetrical framework prevents an image from appearing static and encourages the viewer's gaze to sweep naturally through the rest of the frame. These practical design techniques often blur back into mythology. A prominent rumor claims the Apple logo was meticulously engineered using the golden ratio. The original designer actually drew the shape freehand in the 1970s, and later geometric refinements did not adhere to a strict 1.618 framework. This tendency reached an extreme in 2008 with the redesign of the Pepsi logo. A leaked 27-page document from the design agency justified the new branding by linking its geometry to the golden ratio, Euclidean geometry, and the magnetic field of the Earth. It is a textbook example of corporate apophenia, leveraging mathematical mythology to project profound significance onto a soda brand. The golden ratio is an ingenious mechanical solution adopted by plants to survive, and a highly practical tool for structuring digital interfaces. It does not dictate a universal law of human beauty. Instead, it reveals our deep, relentless human drive to uncover patterns and meaning in an inherently messy world.